here's a sample quote from the book by astronomer M.E.J. Goury-de-Bray. This was quoted in the prestigious journal Nature on April the 4th, 1931. Here's what the quote says. "If the velocity of light is constant, how is it that invariably," his emphasis, "invariably new determinations give values which are lower than the last one obtained? There are 22 coincidences in favour of a decrease of the velocity of light, while there is not a single one against it." I decided to investigate. I expected I'd be able to wrap it up in a couple of weeks. Well, I've had a time problem of my own. Here we are 20 years down the track and it's still going on. It's like an octopus that reaches out into all areas of science. The behaviour of light has always been a fascination for mankind. From the time of Aristotle to the time of Galileo in 1638, the general scientific opinion was that the speed of light was infinite. Few opposed it. In 1638, Galileo decided to settle the issue by doing experiments with lanterns and shutters on hills miles apart, and they discerned no observable delay in the light travel time. So they still continued to believe that the speed of light was infinite. It was not until 1676 that the Danish astronomer Rupert, in an experiment using Jupiter's moons, presented experimental evidence that the speed of light was fast but finite. This ran counter to the prevailing wisdom and evoked intense opposition, which lasted for half a century. Over 50 years later, Rupert was proven correct. In 1728, the British astronomer Bradley confirmed Romer's results by a different method, and the opposition finally died down. Light speed, it was generally agreed, was fast but finite. And scientists then continued to measure the speed of light and check its numerical value. And in over 300 years, 16 methods have been used to determine c. And this has given rise to 164 different determinations of its value. Importantly, it's generally true that, with some exceptions, the measured speed of light kept decreasing. It's true even when the same method was used and the same equipment was used by the same observers. There are 17 occasions where the same equipment was used at a later date and gave a lower result. Now, many well-known scientists were involved, Albert Michelson, Simon Newcomb and others, and in general the consistent downward trend in the C values by all methods was evoking scientific comment. In 1886, Simon Newcomb, writing in the journal Nature on May the 13th, commented that the values of C obtained by the methods used around 1740 were consistent, but they placed the value of C 1% higher than in 1880. In 1941, history repeated itself. Physicist R.T. Burge, who kept track of all the values of the atomic constants, spoke of the values of the speed of light obtained by a variety of methods in the mid-1800s, interestingly some of them by Newcomb. Burge acknowledged in the journal Reports on Progress in Physics that, quote, "These older results are entirely consistent among themselves, but their average is nearly 100 kilometres per second greater than that given by the 8 more recent results." Wow. About that time, physicist N.E. Dorsey stated, "As is well known to those acquainted with the several determinations of the velocity of light, the definitive values successively reported have, in general, decreased monotonously." He was not very happy with the situation. So the consistent downward trend in the measured values of C could not be denied, and a great deal of discussion went on in the scientific journals about this. Over 50 articles in one top journal alone. And the discussion was all the more impressive because at the time the speed of light was generally held to be constant. The problem was that if C was in fact changing and was not constant, was anything else changing as well? Other atomic constants had their values reflected in the rate of movement of atomic particles and their associated energies, and these were presumed to be constant as well. But were any of these changing as well? Measurements over time revealed that some seemed constant, others were apparently changing. And if this was true, it was potentially disruptive to the new physics that was developing. One of the key quantities was something called Planck's constant. What it is and what it does we'll talk about in a few minutes. But the letter H is the mathematical shorthand for Planck's constant. But the point is that Planck's constant H was measured as steadily increasing with time. But when H was multiplied by the speed of light c, the result was always a constant. even when checked astronomically. Therefore, with hc as a constant, if one quantity went up, the other quantity obviously had to go down. So, for example, if hc equaled 12, this could be 12 times 1, or 6 by 2, or 3 by 4. As one changes, the other changes proportionally, inversely. So this indicated that the measurements of h and c, while c was decreasing, h was increasing directly. As mentioned, Burge was the keeper of the constants. He kept track of the variations in the speed of light and Planck's constant and a lot of the others. And then something strange happened in August of 1941. Burge, in an article on the general physical constants, quote, with special reference to the speed of light, had this introductory paragraph reading in part. Listen to what he said. This article is being written upon request and at this time upon request. Any belief in the change of the physical constants of nature is fatal to the spirit of science, as science is now understood.
As my friend Terence McKenna used to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. But I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of only fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. And then in 1945, it went up, 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants. And I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking. So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we've defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem.